Hi, my name is Jennifer Cooling from the University of Queensland, and I'm here, whenever you're watching this, to talk about some work from my PhD project on the palynology of the Jurassic to Cretaceous transition in the Surat Basin of Australia. So just a quick recap for anyone not familiar with it. The Surat Basin is a sedimentary basin covering 300 and something thousand square kilometres of Queensland and New South Wales, consisting of up to 2.5 kilometres of gently sloping, relatively underformed strata. And due to the largely terrestrial nature of the sequence in this basin, up until you reach sort of partway into the Bungle Formation, and actually over most of the Australian Mesozoic, the principal method of dating and correlating the rocks at the basin has been through biostratigraphy, in particular spore pollen palynology. In the Surat Basin, the lower part of the basin sequence from the base through to the Westbourne Formation was studied by various Geological Survey of Queensland geoscientists, and the interval from the Mooga Sandstone through to the top of the basin was studied by assorted Geoscience Australia scientists. As you may have noticed in the last slide, these two study intervals wound up leaving a little bit of a gap here, with in the Surat Basin, the Gubramunda Sandstone and the Jeirolepidacean Formation not having undergone detailed Palynostratigraphic studies. So the correlations between the litho, bio, and chronostratigraphy here are largely based on sort of extending work from adjoining and slightly further afield basins into the Surat Basin sequence. So the principal goal of my PhD has been to do that in-depth biostratigraphical study and tidy up and solidify those linkages. And to cut a long story short, I did. However, as talking about this sort of stuff is apparently a bit dull unless you're one of the small number of people who are really into the minutiae of how Australian stratigraphic correlations are made, what I'm instead going to talk about is what the information I gathered in the course of this biostratigraphic study can also tell us about the paleo environment, flora, and climate of the Surat Basin at the time of the Jurassic to Cretaceous transition. At the time of the Jurassic Cretaceous transition, the Surat Basin was an intertectonic one located maybe a few hundred kilometres inland from the southern coast of Gondwana. It was these formations, the Upper Westbourne, Gubramunda, Orello, and Mooga, were all deposited in a fluvial setting of alternating lower and higher energy environments. Paleogeographic reconstructions for Australia at this time period are variably constrained, but generally place the basin somewhere between 50 and 80 degrees south of the equator. Based on previous palynological and paleobotanical works, the climate in this period is inferred to have been somewhere between the cool temperate to subtropical range. So to carry out this study, I took biostratigraphic samples from 3 GSQ stratigraphic boreholes in the west, centre, and eastern parts of the basin. From these samples, I found all of the samples were productive, and they yielded a fairly rich and diverse Paleoflora of 218 morphological species from across 108 genera. So the bulk of these were from spore-producing plants, but with a fair component of pollen, and then increasingly small portions of algal palynomorphs, spinous acritarchs, and fungal or uncertain affinity. So just to give you an idea of what the sort of raw data look like for the stratigraphic purposes, here are the palynological results for GSQ Roma 2 with Palynomorphs grouped by genus. So the first step in taking any sort of raw biostratigraphic palynological data and starting to consider it for paleo-environmental, ecological, floral stuff is to go from your palynological species and genera, which for paleo stuff are always morphological species and genera, and link them to what plants actually produce them. Luckily for everyone in this field, there is the massive catalogue pulled together by Basil Baum, who went through every instance where people found a fossil containing of a plant from which they could extract from the spore or pollen producing body, palynomorphs, and go, on this basis, we know, for example, the palynomorphs we refer to as Glyconidates were produced by the Glyconidaceae ferns. So, using this big table of botanical affinities, my data also looks like this, which, even though the lines do squiggle around a fair bit, overall there isn't a really major change in the broad composition of the Paleofloras based on their botanical affinities between the different wells and from the Westbourne through to Mooga Sandstone. And in general, the assemblages are composed of about 50% of a variety of ferns, but in particular the Osmundaceae and the Matoniaceae ferns. Then broadly 20% each of lycopods, which are the sort of squishier relatives of the ferns, and the conifers, particularly the Araucariaceans. And then with seed ferns, bryophytes, cycads, ginkgos or knee-tails, they're based on palynomorphs, they're quite tricky to distinguish, algae and acrotarchs. So before we go any further, I do need to give a couple of quick caveats. 150 million years is actually quite a long time, and most of these botanical affinities are at the level of the family, not a genus or species. So some of these plant groups have since become entirely extinct, such as the Cheirolepidacean conifers, and others, such as the Matoniaceae ferns, now inhabit a much reduced geographical and probably paleo-environmental range. In addition, one palynomorph is not directly, there's not a one-to-one relationship between number of palynomorphs produced and number of plants producing them. Some plants are, in the modern record, generally over or underrepresented. Despite that, this is often the best evidence we have from these sort of intervals, and so we can draw some broad stroke conclusions. With the high ratio of fern spores relative to conifer pollen I've seen in my samples, they're pretty much all assignable to the back swamp or floodplain facies of Pelzer et al. 1984. In addition, based on the very low abundances of Microstridium and the absence of any other indicators of brackish or saline conditions, this interval appears to have been deposited in a strictly terrestrial setting. And this may correspond with the Cretaceous sea level nadir in the mid-Valanginian. So the Paleoflora can be interpreted as a diverse assemblage of ferns growing on the lowlands between waterways and shallow lakes, with an extremely diverse assemblage of lycopods and bryophytes growing alongside, and with conifers and seed ferns growing on higher and dry lands under warm temperate conditions. Thank you for your attention and have a good day.